Introduction.
Hey Radha, what are you doing? Wow, very beautiful. How do you make this? I made this with the help of compass and pencil. But do we really need a compass to make these circles? Yes, to make an accurate figure, we need all these geometrical stuff. Can you see this angle? Yes, it's a 30-degree angle. I have made this with the help of a compass and a ruler. But how? I also want to learn. Come with me. I will teach you.
Objectives. At the end of this lesson, you'll be able to bisect a given angle, draw the perpendicular bisector of a given line segment, construct an angle of 60 degree, etc. Construct a triangle given its base, a base angle, and the sum of the other two sides. Construct a triangle given its base, a base angle, and the difference of the other two sides. And construct a triangle given its perimeter and its two base angles. Definition. Construction in geometry means to draw shapes, angles, or lines accurately. These constructions use only compass, straight edge, that is, ruler, and a pencil. In some constructions, we may also use a graduated scale and protractor, where measurements are also required. Bisector of a given angle. Friends, we know how to construct a circle, a perpendicular bisector of a line segment, angles like 30 degree, 45 degree. Now we will learn to construct the bisector of a given angle. Let us take an angle ABC. We have to construct the bisector of this angle. First of all, taking B as center and any radius, we will draw an arc to intersect the rays BA and BC, say at E and D respectively. Next, by taking D as center and with the radius more than half of DE, we will draw an arc. Similarly, by taking E as center and with the radius more than half of D, we will draw another arc which intersects the first arc at F. Now draw the ray BF. This ray BF is the required bisector of the angle ABC. How can we say that BF is the angle bisector? Let us prove this. Join DF and EF. Now in triangles BEF and BDF, BE is equal to BD because these are the radii of the same arc. EF is equal to DF because these are the arcs of equal radii. BF is equal to BF, common. Therefore, by SSS congruence rule, triangle BEF is congruent to triangle BDF. This gives angle EBF is equal to angle DBF by CPCT. Hence, BF is the angle bisector. Perpendicular bisector of given line segment. Now we will learn to construct the perpendicular bisector of a given line segment. Let us take a line segment AB. We want to construct its perpendicular bisector. Steps of construction. Firstly, taking A as center and radius more than half AB, draw arcs on both sides of the line segment AB. Similarly, taking B as center and with the same radius, draw another arcs on both sides of the line segment AB, which intersects first arcs at point P and Q. Now join PQ. Let PQ intersect AB at the point M. Then, line PMQ is the required perpendicular bisector of AB. Let us now prove that PMQ is the perpendicular bisector of AB. Join A and B to both P and Q to form AP, AQ, BP and BQ. Now in triangles PAQ and PBQ, AP is equal to BP because these are the arcs of equal radii. AQ is equal to BQ because these are also the arcs of equal radii. PQ is equal to PQ, common. Therefore, by SSS congruence rule, triangle PAQ is congruent to triangle PBQ. So, angle APM is equal to angle BPM by CPCT. Now in triangles PMA and PMB, AP is equal to BP, arcs of equal radii. PM is equal to PM, common. Angle APM is equal to angle BPM as it is proved above. Therefore, by SAS congruence rule, triangle PMA is congruent to triangle PMB. So, AM is equal to BM and angle PMA is equal to angle PMB by CPCT. Now by using linear pair axiom, angle PMA plus angle PMB is equal to 180 degree, or we can write it as angle PMA is equal to angle PMB, which is 90 degree. Therefore, PM, that is PMQ, is the perpendicular bisector of AB. Assessment. Before proceeding further, let us know how much you have learned. Click the correct option. Angle of 60 degree. We know how to construct 30 degree and 45 degree angles. Now we will learn to construct an angle of 60 degree at the initial point of a given ray. Let us take a ray AB with initial point A. We want to construct a ray AC such that angle CAB is equal to 60 degree. Steps of construction. Taking A as center and some radius, draw an arc of a circle which intersects AB, say at a point D. Now taking D as center and with the same radius as before, draw an arc intersecting the previously drawn arc, say at a point E. In the next step, draw the ray AC passing through E. Then angle CAB is the required angle of 60 degree. Now let us see how this method gives us the required angle of 60 degree. Join DE. Then by construction, AE is equal to AD, which equals DE. Therefore, triangle EAD is an equilateral triangle. Also, triangle EAD is an equilateral because angle CAB is equal to 60 degree. Construction of a triangle. To construct a triangle, given its base, a base angle, and sum of other two sides are given. Let ABC be a triangle in which BC be the base, B be a base angle, and AB plus AC be the sum of the other two sides of a triangle ABC. We need to construct triangle ABC. Steps of construction. Draw the base BC and at the point B make an angle, say XBC, equal to the given angle. In the next step, cut a line segment BD equal to AB plus AC from the ray BX. Now join DC and make an angle DCY equal to angle BDC. Let CY intersect BX at A. Then ABC is the required triangle. Let us now see how we get the triangle ABC. Here in triangle ACD, angle ACD is equal to angle ADC by construction. Therefore, AC is equal to AD, then AB is equal to BD minus AD, which is equal to BD minus AC, or AB plus AC is equal to BD. We know that the sum of two sides of a triangle is greater than the third side. Therefore, ABC is a triangle. Now we will construct a triangle when its base, a base angle, and the difference of the other two sides is given. Given the base BC, a base angle, say angle B, and the difference of other two sides. Here we have two cases. The difference can either be AB minus AC or AC minus AB. We have to construct the triangle ABC. Let's first construct the triangle using case first when AB is greater than AC, that is, AB minus AC is given. Steps of construction. First of all, draw the base BC and at point B, make an angle, say XBC, equal to the given angle. Now cut the line segment BD equal to AB minus AC from ray BX. Next is to join DC and draw the perpendicular bisector, say PQ, of DC. Let it intersect BX at a point A. Join AC. Then ABC is the required triangle. Let's now construct the triangle using case second. Let AB is lesser than AC, that is AC minus AB is given. Steps of construction. First of all, draw the base BC and at point B, make an angle, say XBC, equal to the given angle. Next is to cut line segment BD equal to AC minus AB from the line BX. Now join DC and draw the perpendicular bisector, say PQ of DC. Let PQ intersect BX at A. Join AC. Then ABC is the required triangle. Let us now construct a triangle given its perimeter and its two base angles. Say angle B and angle C be the given angles. Also, BC plus CA plus AB. We have to construct the triangle ABC. Steps of construction. Firstly, draw a line segment XY which is equal to BC plus CA plus AB. Make angles LXY and MYX. Now bisect angle LXY and angle MYX. Let these bisectors intersect at a point A. Next step is to draw perpendicular bisectors of AX and AY, that is, PQ and RS. Let PQ intersect XY at B and RS intersect XY at C. Join AB and AC. Then ABC is the required triangle. Example. Let us now look at one example in which we have to construct a triangle ABC, in which angle B is 60 degree, angle C is 30 degree, and AB plus BC plus CA is equal to 15 centimeter. Steps of construction. First of all, we will draw a line segment PQ is equal to 15 centimeter, which is equal to AB plus BC plus CA. Now at P construct an angle of 60 degree and at Q an angle of 30 degree. Bisect these angles. Let the bisectors of these angles intersect at a point A. Now draw perpendicular bisectors DE and FG to intersect PQ at B and C. Join AB and AC. Then ABC is the required triangle. Then ABC is the required triangle. Assessment. Now answer the given questions. Fill in the blanks with correct option. Did you know? The word geometry comes from the Greek words geo, meaning earth, and metria, meaning measure. Along with arithmetic, geometry was one of the two fields of pre-modern mathematics. Ancient Egyptians used geometry principles as far back as 3000 BC, using equations to approximate the area of circles among other formulas. A Greek mathematician named Euclid, who lived around the year 300 BC, is often referred to as the father of geometry for his amazing geometry works that included the influential elements which remained the main textbook for teaching mathematics until around early 20th century. The construction of the triangle is not possible if the sum AB plus AC is less than equal to BCE. Summary. Let us summarize what we have learned. Bisecting a given angle, drawing the perpendicular bisector of a given line segment, constructing the given angle, constructing a triangle when its base, a base angle, and the sum of the other two sides are given, constructing a triangle when its base, a base angle, and the difference of the other two sides are given, constructing a triangle when its perimeter and its two base angles are given.